will be there on YouTube and
Okay.
other platforms. So I
Yeah,
think we will proceed.
ठीक है. Okay.
Okay. So
Yeah.
we will start. Ladies and gentlemen, esteemed colleagues, and my dear fellow students, Namaskar and good morning to everyone. We are very grateful to our Honorable Vice Chancellor, Professor Nageswar Rao sir, and respected Pro Vice Chancellor, Professor Uma Kanjilal Madam, for their timely guidance and helping us during the various planning session of these knowledge transfer series sessions. These sessions are designed to foster intellectual growth and facilitate the exchange of ideas among all the learners who are interested to understand different areas of computer science and information technology. Today, we are gathered here for the sixth lecture on emerging transportation solution driven by Industry 4.0 transformation. A very special thanks to our today's speakers, Dr. Anuj Sharma, Professor, Iowa State University, USA, for readily accepting our invitation in a very short notice. He has consistently used his expertise to address some of the most pressing global challenges. Sincere welcome to Professor Suresh, Director SOCIS, all the directors, regional directors, center heads, and colleagues from SOCIS, including different faculties from different schools in IGNOU. I would also like to extend a warm reception to our enthusiastic participants who come from the very diverse background, including academia, industry professionals. A special mention goes to our young and promising learners who have enrolled in BCA, MCA, and PhD programs. So today you have joined us for the noteworthy online knowledge transfer series, which is organized by the School of Computer and Information Sciences at IGNOU. IGNOU, as the world's largest open university, promises to bring a unique and innovative dimension to these sessions by featuring speakers from various fields. I extend my gratitude to each and every one of you for unwavering commitment to the pursuit of knowledge. Together, let's continue our journey of knowledge, exploration, and growth. Thank you once again for giving this opportunity to coordinate these knowledge transfer series. Thank you, sir. Now I request Professor Suresh, Director SOCIS, to address the gathering.
Thank you, Professor Sandeep. First of all, it's a warm welcome to Professor Anuj Sharma. Thank you, sir, for joining us. Maybe otherwise you must have been at the bed. And thank you for delaying the night sleep for the sake of the Indira Gandhi National Open University. IGNOU is a university where we have 34 lakh students on enrolls. And we had another 35 to 40 lakh students who have already graduated. So as on date, our student enrollment is around 34 lakh students. And we are spread across the country as well as outside the country also in many foreign countries. This is the only university with both national and international jurisdictions in the country. So here in Delhi, the temperatures are very low. I do not know on your side, but still I would like to extend a very warm welcome to you. I also thank our Vice Chancellor, Professor Nageswar Rao ji, who kindly permitted us to launch and offer this series, knowledge transfer series that was initiated by Professor Sandeep Singh Rawat, Professor in Computer Science. And this is the sixth lecture in the series. And I also thank our PVC Professor Uma Kanjilal, who may be joining after some time online. And to introduce Professor Anuj Sharma, he is a professor in Civil Construction and Environmental Engineering Department at Iowa State University. He also holds a joint appointment as a research scientist with the Institute of Transportation. And in these positions, he teaches transportation engineering courses to undergraduate and graduate civil engineering students, conducts research in the transportation operations area, and participates in numerous professional organizations. His research was recognized by many funding agencies. The high-performance cluster assembled for the lab is able to ingest multiple streams of real-time data from multiple sources. One can Google his name go to the page and even click on the lab's website. The link was available. And sir, we are very much honored to have you today. And Professor Anuj is having many honors and awards to his credit. And it's a very big list. So it's always better that you visit his website, that you get inspired that in such a short time, how to do so much of valuable work. I often hear that in some countries, the wastage of time is very less because you don't need to wait for anything. But I don't know. Maybe that may be one of the reasons that you have so many accolades. Thank you very much, sir. And you can also throw some light during your lecture on how students of computer science can diversify into the areas such as transportation engineering and other areas which are of very much importance almost for every country. So you can throw some light so that students can think from that perspective also. And today's lecture is Emerging Transportation Solutions driven by Industry 4.0 transformation. As part of this lecture, normally we all are aware that the transportation systems are very much advanced in Japan. Okay, people say that even if that local train is delayed by a minute, you will be receiving an apology. And if it is delayed by maybe 5-10 minutes, you may even get a refund. So in case Japan is the country with most advanced transportation solutions, I do not know whether I'm true or not. Is there anything over and above it which is going to come up in the future to take care of the problems in those countries which are having very advanced transportation systems? If time permits, you can throw a bit of light on that also. So thank you very much, sir. And now I hand over to Professor Sandeep.
Thank you, sir. In fact, I just want to add, like most of his scholars whom he is guiding and all, they are from computer science background. So I was also his student actually at Iowa State. So he's working mostly on the computer science related areas and all. Yeah. So thank you very much, Professor Suresh. The moment we have all been waiting for is here. I kindly ask all the participants to please mute their microphones and turn off their cameras. If you have any questions during the presentation, feel free to use the chat box to send your queries, and we will address these questions during the question answer sessions. Feedback form will be shared at the end of the session. Please remember, those who will fill the feedback form will only receive the certificate after the verification. So thank you, Dr. Anuj Sharma, for gracing us today with your presence and for being a beacon of knowledge, inspiration for all of us. The stage is now yours, and we are eagerly await for your words of wisdom. Dr. Anuj.
Thank you, Professor Sandeep and Professor P. Venkata. I'm excited about this session, and I hope this is useful for the students who are attending as well. Feel free to write your questions in the chat, and then towards the end, we'll answer all of them. At least try to answer all of them. Otherwise, if there are still some questions remaining, I would work with Professor Sandeep and get the responses back. So let me share my screen, and hopefully you are able to see my screen now. Is it working?
Yeah.
Okay. So I'll be talking about emerging transportation solutions driven by Industry 4.0 transformation, and talking a little bit about what Industry 4.0 transformation actually mean. But prior to that, let me say that I'm happy and for so much warm welcome. And this is what AIMS looks like today. This is pathway to my house. So you can see it is minus 10 degrees Celsius right now here. And it is supposed to be another 4 or 5 inches of snow. So all the warm welcomes are actually very welcome, and hopefully those will keep us warm. But let's get started with the presentation. So what I'll be doing is I'll be talking from my experience in USA, but I have been also working very closely with the researchers in India, and I'll try to make sure that some of the concepts which I'm talking about actually are tied back to how these things can be implemented in India as well. So as per any country, the traffic demand, which is the number of people willing to travel using a vehicle, is increasing at a high pace. And in US, it is increasing at 1 to 2% annually. But the amount of money we have to construct roads, uh, at least in US, comes from the gas tax. What gas tax means that every time you put petrol in your car, there is a certain amount of tax which is charged for that, and that money is used for um, constructing roads. And as the cars become more efficient, or we are moving towards electric vehicle, the amount of money which is being collected as taxes is getting less and less. So because of that, we cannot what we say construct our way out of traffic congestion. So the people who commute daily to work essentially are seeing more and more congestion, approximately 1 to 2% every year. The number of the percentage of time you have to wait stuck in traffic increases. And if you have driven in Delhi, you would appreciate that how the congestion, despite the fact that metro was brought in, the congestion was increasing prior to COVID times. It went down a little bit because of COVID, but now it is picking back up again. So most of the countries are facing these challenges. The other big challenge with transportation is the fatalities happening on roads. So Nations General Assembly wanted to half the number of global deaths which are happening because of crashes by 2030. But it is one thing to set up a goal, but then to follow up on it, you require a lot of planning. That needs to happen. And how can we do it? So essentially, this is the goal of the presentation, to show how with the limited amount of resources that we have got, how can we essentially operate our system in a safe, efficient, and equity-based method within the existing budget. One thing to remember is that any system can only be changed without consuming exorbitant amount of resources, is by using disruptive technology, and hopefully we can use the disruptive technology in transportation as well, so that we can improve the performance without the need of very much additional resources. So just to go back to what industrial revolution, what do we mean by Industry 4.0 revolution? This chart presents that what have been the industrial revolutions, which some of you might have remember from your history classes, that Industry 1.0 revolution was basically mechanization of an introduction of steam and water power engines. And what it did was that people usually previously used to live very close to places where abundant food was available, abundant clothing was available. So most of the early civilization happened very close to a river. But as we became bigger and bigger, because of Industry 1.0 revolution, what could happen was that the steam and water power could be harvested, and you could transport a lot of these goods further away from their sources. So if you wanted to bring coal from the coal mines to drive something, there was railway locomotive available to move this coal from the coal mines and bring it to places where people might need it. So that was a big significant change in human civilization, where the civilization started spreading away from the source where all the things were available. The 2.0 revolution is when we started mass producing in assembly line using electric power. So instead of individual people producing goods. Like, for example, a person is handcrafting a shoe, or a person is stitching a cloth. Instead of doing that, when there was a mass production where industries were built that you can produce hundreds of thousands of shoes per day, that is where Industry 2.0 revolution comes into play, that the assembly line was put together. Finally, 3.0 revolution happened recently, where some of the tasks which were being done in the factory were automated using computer and IT systems and robotics. So in that case, what happened is that the computer would individually look at some of the processes, and those processes were automated. For example, if a boiler has to run at a certain temperature, there was a logic that if the temperature falls below 24, turn on the heat, and if it is over 35, reduce the heat. And those kind of automation started coming in, which was very important. What Industry 4.0 revolution entails is machines talking to each other. So basically, it is a smart factory where human intervention is minimal. If in assembly line some order is missing, it is automatically ordered and the raw material is brought in. Similarly, when the raw material is going to come in, if we think that we'll need a lot of water or coolant, that is automatically ordered as well. So it is dependent on Internet of Things. It is dependent on robotics, and they communicating with each other, so that the human intervention is minimal. In the same vein, we can say the transportation system also had similar revolutions which we were going through. The first revolution essentially is when we moved away from horses and started having locomotive engines in our system. That I'll define as the first revolution. The second revolution can be defined as where we started mass producing cars. So previously, only people with a lot of money could afford a car, but eventually, because of mass production, the cost of cars went down, and we started having more cars on the roadway. And finally, 3.0 revolution, actually introduction of automobile is the 1.0 revolution. The 2.0 revolution is not only the automatic mass productions of car, but also really significant development in the interstate system as well. So interstate system in US is equivalent to the national highway systems in India. So if you think about the current national highway systems, the travel time on the roads have significantly been reduced. But what it also does is it pushes more speed related crashes and things like that. The next revolution which happened in transportation industry was to put sensors, so that when something goes bad, we are immediately notified that, oh, this place is having congestion. Maybe you can avoid that road, or if there is a crash on the road, someone can go and help that. So that has been happening previously, but now the next revolution, what 4.0 revolution, which I'm talking about, is when we are combining the data from different sources. We are using AI, artificial intelligence, to automatically do some kind of analysis. Instead of using simple machines, we are using cloud compute, and then all these environments are talking to each other, so that the system can be controlled easily. So the question becomes is why is this happening right now? And there are three big drivers of such a revolution. One is that the cost of computing has gone down significantly. So if you even look 10 years back or 15 years back, a really powerful system was Pentium 2.0 or Pentium 3.0. But in last almost 2 to 3 decades, we have seen a big drop in price of compute. What it does is that it allows all these machines to, even cheap machines, to have a lot of brains in them. So that is one thing. The second thing is that the cost of transmitting the data from point A to point B has gone down. So even the cell phone plans, which used to be that you can buy X GB of data by paying some money, you can buy more and more data for the same amount of money. And finally, the amount of storage which is available to save this data is also becoming cheaper. So now you can produce more smart data. You can transmit that smart data, and you can also save it bigger and bigger data sets and at a cheaper price. So that has led to a significant data growth. So in terms of just in US, this is what I have been dealing with. Previously, we probably used to have some surveys done on how many vehicles are on the road to design our system. So if we did maybe 100 surveys per year, and every day we produces around 32 lines of data, we had only 3,200 lines of data for the whole year, and a single person with access to Excel could process that data. Over time, what happened is we started putting sensors on the road, which were there to measure how many people are passing on a specific segment of the road, what is the velocity of those folks, and what kind of vehicles they are traveling with. So once we started deploying these sensors, we started getting, like, if we deployed 500 sensors, we were getting 262 million rows of data. So although so from 3,200 rows to 262 million rows, the Excel couldn't handle it. Then what we started getting was the data from the cell phone providers, that if you have a cell phone, similar to how Google gets the data on where there is congestion or not, we are able to get the data from each individual cell phone, and that is equivalent to 75 billion rows of data. So from 2000 to 2023, our data size increased from 3,200 rows to 75 billion rows just for a single state, which is 75 billion rows is around 6 terabyte of data in a compressed format. So when we were dealing with only 3,200 rows, I can use my home laptop and use my Excel to process a lot of things. But when we are talking about 6 terabytes of data that is compressed, then we start needing some heavy compute. So in last 2 decades, as I was mentioning, that the data has grown 23 million times, but the number of people who are there to mine this data, or the number of employees who look at this data, are still the same, because the money is not growing. The government is still spending the same amount of money to build roads. So this just shows you a comparison of what those number 3,200 and around or 75 billion numbers looks like. So if previously we were observing one oak tree or one tree of Ashoka, now we have basically a whole jungle which we have to observe. And that whole jungle was previously present, but we didn't have means to observe what was going on in that jungle. So now with this additional data sets, you have a better control on what is happening in your area. So the other thing is the data has grown significantly, but also our skills have become more and more powerful. So now we have got on cloud ability to do stream compute as well as batch compute, and the brain behind the system is also becoming more powerful. So if you have heard of deep models, we are able to deploy some of these deep models to process huge amount of data and make sense out of it. So the other thing which has happened is a lot of companies out there have open sourced their toolboxes. So previously, when in around 2008, around 2008, 2009 time frame, Hadoop was open sourced, and then TensorFlow is open source, PyTorch is open source. So it is not just people who are very strong in C and have the ability to write code so that you can parallelly process the data, can work with this kind of data. Instead of that, by open sourcing all these code, what they have done is they have made it possible for basically people with less computer background also handle big data. So if you see some of these libraries, now it is possible to just write a SQL query, and on the back end, that SQL query can be converted into the whole batch processing system, and then that batch processing MapReduce can be run on a Hadoop cluster. So as a user, you don't have to worry about what is going on in the backside. The open source tools can take care of it. So we have used all these tools to actually work and make better decisions in our transportation system. And what I'm going to show is some examples how we are using some of the technologies which I talked about to make better decisions, to have improved decisions in our system. The decisions are being taken at multiple levels. What I call is in health, in control, and insight. The in health is for detecting if there is errors in the detection system itself. In control is doing real-time control, and then insight is more of a planning level controls. So just to give you some ideas about the projects which we have been working on, what I wanted to show is, even in current system, when you deploy CCTV cameras, which you see, there are a lot of human beings sitting and looking at these cameras to try to figure out if there is an issue in the system. So even Delhi has deployed a lot of cameras. What there is a person maybe sitting and looking at the cameras during peak hours to see if some issues are going on. If there is issue, they will send a police car there. But here, what happens is, if you are monitoring, like say 500, 600 cameras, it takes you a long time to find out whether an issue has happened or not. And if you're traveling on a road where there's a lot of congestion, you can have another crash happening by the time you go back and look at that same camera. So what we need is a system that can automatically process the camera feeds and tell you if there has been a crash in the system. So what we did was we developed this algorithm, which was basically first detecting the cars which are coming through. So this is just a simple deep model, which is detecting the vehicles which are coming through. After looking at the vehicles which are coming through, which we were assigning them IDs so that the same car gets the same ID frame after frame, and we can actually track a vehicle. Once we started doing the trajectory plots, then we can easily identify if a trajectory is in a place where it shouldn't be. So if when the car comes and stand on the side of the road, our algorithm can pick up that there is some issue with this car, because this trajectory, the car is not supposed to be here. We further improved this algorithm to make sure that when it gets really congested, we are not, our system is still detecting. So for example, when the congestion grows really fast, our system is still detecting these cars which are parked on the side of the road, which was very critical when you are doing a lot of incident detection. So this algorithm was basically, we used a lot of off-the-shelf tools, and we were able to design such an algorithm very quickly, which can be deployed on cameras for detecting incidents. The problem with detecting incidents using camera is that the cameras cannot be present anywhere. Like maybe there are, say, 500 cameras or 1,000 cameras, but you have so many lane miles that you cannot possibly have camera covering every single bits and pieces of your road. So where there is camera, you can use this technology which we are talking about to do incident detection. But when there are no cameras, becomes difficult. So we looked at other sources of data. So this is somewhat similar to a cell phone data, which maybe your smartphone is sending back to Google. We were able to buy that data, and that data we were able, like if you look at a breadcrumb plot of where the GPS location of your vehicle is, we could plot that across the roadway. So what you can see is that this is one of the crash which was captured in our camera, where a car came in front of the truck and things went bad. In this scenario, since there is camera, we could easily pick it up from camera, but there can be cases where there is no camera. And what we started doing was, can we use that cell phone data to detect issues which are happening in your system. So essentially, the crash happened around 6:54. We started a lot of red happening and moving backward. And if we have an automated algorithm, which we now have, we are able to detect these crashes at any place where there is a little bit of traffic present. So what I'm showing over here is on the x-axis is time, and on the y-axis is distance from a reference point. And when the slope is when the lines are having greater angles, which means that angle greater than say 60 degree or 70 degree, that means the vehicles are moving normally. Each line represent a single vehicle. But as you see that at 6:52, when the crash happened, you can see the vehicle started to stop and things like that. The flatter the slope is, the lower the velocity is. So just by using this cell phone based data, we are also able to detect these crashes which might happen on the road. So that gives us a huge coverage. And we did some experimentation in terms of how long does it take for us to detect a drop in speed, and we found out that it doesn't take too long. Within around 18 to 20 seconds, we are able to detect if there was a problem on our roadway, which is much faster than if there was someone who was going to call the police department and have people come in with help. So this is a very critical technology. Finally, one of the things which I wanted to show is that when we are talking about saving accidents, a lot of low-hanging fruits where there are a lot of accident going on has already been picked up. So we need a system which can actually go through and pick up all the oranges which are there. So basically, what we have designed is based on the cell phone data. Essentially, it is similar to cell phone data. It is directly coming from the car. We call it connected vehicle data, but you can think of it as a cell phone data. We have associated that data with other sources of data. So essentially, I get the weather data. I get the data from police department, whether the crash has happened or not. I get the data from other places where there was weather, snowstorm or something going on. By combining those data sets, we are able to plot number of braking events which are happening, where people are actually applying heavy brakes. So instead of just looking at crash, we are looking at the surrogate measure of safety, that how many people are actually applying brakes, heavy braking, and we are able to locate certain areas where a lot of heavy brakes are being applied. And then we are going and looking into those specific segment is what is going wrong and improving those segments. So instead of waiting for a crash history to develop, now you can use the surrogate measure just by using the data which you already have available, and try to solve some problems there. Similarly, the power of visualization, I just wanted to explain this is the chart which was created by a doctor in London. And what he did was he just there was a cholera outbreak, and no one knew why it was happening. What he started doing was as the patients were coming in, he started putting a small bar from where the patients are coming. And you can see that the cluster center where all the bars were stacking up was close to this hand pump, and they realized that the hand pump had an issue. So you don't even have to do a fancy analysis. If you have enough data, even data visualization can give you a lot of insights. So similarly, we have built a system where we are basically for every crash that happens in the state of Iowa, we try to find if there's a camera close by, and identify what is going on. And we saw that this is a specific area where there were a lot of crashes happening or accidents happening during rainy season. So we saw almost 4 to 5 accidents happening at this specific roadway only when there is rain. And what we were seeing was there is a stream of water flowing through, and which was hydroplaning the cars. Hydroplaning implies that if the cars are traveling at a very fast speed and they travel over a thin stream of water, they might lose control and spin. So by looking at this data, we found that there is cluster of crashes happening over here. We went ahead and checked what was going on, and we had a clogged sewage system which was causing this. So just by combining all the data which you have in position and doing something critical, you can find issues which you might be able to solve and save lives. Similarly, we have looked at the fatalities which are going on in Iowa, and we realized that safety seatbelt has been a big issue which is popping out, where people who are not wearing seatbelts have a very high percentage of fatalities are happening when the driver is not wearing a seatbelt, which is a number which is really mind-blowing, because almost 40 to 50% of fatalities which are happening, they involves a person who is thrown away from the car and lands somewhere where their head or neck hits something and they die. So seatbelt is very important there. We also started looking at each fatality very specifically, and trying to figure out if there is a specific problem. In this case, the light turns yellow just right here, and we see that the car from the other side keeps moving, and this car just banks it. So if it was an individual event, we might say that it is a fault of the vehicle, but we started going back and tracking more of such incidents, and this is in a poor weather condition, and we'll see that the car keeps moving, and again there's a hit over here on the same intersection. This is happening at the same intersection, so we can identify that there might be an issue with the signal changing from red to green, and previously people were lucky to not get killed, but if we ignore the signal, there might be a potential crash over here. So essentially, the bottom line is, once you have data in place, it's not just about keeping not just about having the data, it's about finding insights in the data and trying to solve the problem. Finally, I wanted to show that some of the models which we have built, where we are tracking people while they are driving, the models are able to detect what kind of action you are taking on your drive. And these models are very useful to find out naturalistic behavior of drivers as they are driving through. So we don't need to have a human annotate all this data. We are just able to use the deep models to identify what is the surrounding conditions, what are the actions they are taking. The other thing we have developed is a model for actually detecting driver distraction. So for example, when the person is talking on phone, our model is saying, okay, the person is talking on phone. The other kind of distraction we were looking at were yawning. So in this case, he's yawning. We are able to pick it up. Our model is able to pick it up very nicely. So when we have models like this in future, the cars might be able to see what you are doing in the car and might be able to warn you that if the action persists, you'll have higher risk. So in this case, he's trying to drink water, and it is detecting that the person is drinking water. So I think with this, I'll end the formal presentation on technical topic. I like to introduce you two more things about some of the competitions we do for the people who are interested in getting access to the data set and building their own models. So we have something called AICT Challenge. If you search AICT in Google, you will be able to find that challenge. The challenge would again be open in January. We provide 5 tracks, and people worldwide actually submit their models and see how good they are doing. So if any one of you is interested, please do search the AICT challenge website would be up shortly. You will see 2024 challenge posted, and then you will be able to run your analysis. One of the good things is that if you are one of the top teams, you are invited to make a presentation. But the team which wins, there are 5 tracks. For every track, we also have NVIDIA GPU as a first prize. So do participate if you are interested in that. The people who are interested in joining grad school, there is this company which I have opened up, which matches the grad student with potential advisor. So if you don't know who and which faculty is working in your specific area, you can download this app called Colty, and you will be able to search for different faculty who might be working in the area you are interested in, and then you can try to contact them. So we are having a session on January 30th during your 7 p.m. Eastern, which would be basically your January 31st morning. But we will be talking about if you want to be preparing for grad school, or if you want to do internships in academia. Those are the topics we'll be discussing. So if you are interested in learning more, you can again follow us on LinkedIn by searching for the name Colty, or you can even just send me an email. I can give you more information. So with that, I will open up the floor for any questions. It is around 30 minutes. I want to save some time for answering the questions as well. So thank you all for your time, and let's see what are the questions.
Thanks to Dr. Anuj. I think my video is not turning up.
I can see you.
You can see me? Okay.
Yeah.
Okay. Right. So I think thank you for the excellent presentation, and definitely I'm very much confident that your session has enriched everyone's knowledge and understanding. So what we'll do, we'll take few questions. So learners or all the participants, if you have any questions, you can write it in the chat window there. In fact, even I have one question here, because I think many of our students, because you have mentioned about that tools you guys are working on. So many of our MCA learners, even they were asking like how to get admission into those foreign universities, or how to get, because as part of MCA or BCA they have to do the project, right? And many times they I have a two question in that. So one is like how to get enrolled into the foreign universities, and second thing is when they're doing the project and all, how do they approach the professor? Because that is a one question I frequently get on my email IDs, and another thing maybe you can actually help on this.
Sure. So in terms of applying to grad school, it is a very tedious process, and that's why if I go back one slide, we have started this specific app to help that out. But in general, the policy is that we usually look for 3 things when we are hiring students. One is their GPA. So if they should have a strong GPA, because that shows that they have been working hard. Second is if they have some kind of an internship, so that we know that they have relevant experience. And the third thing which we look for is how motivated the person is, like how can they show motivation for doing the grad studies. So if they have any if they plan to go for grad studies, they might want to build their resume towards those 3 things, is try to get more projects done. Maybe if they are able to participate in some of the challenges and win it, that would be a very good thing on their resume. And also there are times where if they are able to do some internship, because some of your students are already employed people, so they can show from their work that they are working in relevant areas. So that would be very useful. In terms of for their projects, where should they get the data? I would say that the best place to get the data is when there is a challenge open, because even if they don't win the challenge and they do something good with the data, we are providing the data for free. So they have access to the data, they have access to the benchmark, and just by competing and finishing that process. And this is just one challenge. AICT is just one challenge. A lot of conferences have a lot of challenges. I know Kaggle has a bunch of challenges listed there. So I think, especially for computer science people, there is no lack of good data available. Even they don't have to collect it. Someone has already collected it and shared it with you. And these conferences are top-notch conferences. Like AICT Challenge happens with CVPR, which is Computer Vision and Pattern Recognition Conference. There are a lot of IEEE, IV, IEEE, ITSC conference which have some data competitions going on. So if anyone has a specific problem and they would want to know where to look for the data, feel free to have them send me an email. So I'll be happy to help.
Right. Thank you. And I think one of the student, Yashasvi Raj, is asking which type of clustering approach should be used to accumulate such huge data and get proper insight of that data.
So what I tell students to do first is uh, visualize the data. And sometimes data visualization is a big challenge. You have access to such huge amount of data, but if you cannot visualize the whole data set, derive some features and visualize those features. There are a lot of good tools available out there. Tableau is one. In Python, there is multiple libraries. Once you know what is the underlying nature of your data, then you can use different clustering approaches. Uh, like you can use dbscan, k-means, all those things. There are tools available to even find cluster in big data sets as well. So it completely depends on your problem, how big the data is and what you're doing. But I would say that before jumping into any modeling or clustering, try to visualize the data using some common measures.
Okay, got it. So I think, as you have mentioned, in fact, one of the sessions we are also planning to have it on working with the Tableau. So I
Okay.
think yes,
That would be good. I think at least in US, Tableau was free for students. So I don't know if they have the
here,
same deal for India.
here also I think they have made it. Or
Okay,
for the student, they have made it free.
yeah. So
For,
that is one of the best tools I have like
yes.
played with. So that would be good.
Mhm. Okay. Or any other question? Let me just check here. Okay, I think I have one question. If you just go back there in the previous slide, I think one of the slides you was mentioning about not here, maybe when you was talking about the three data set, real time something you was working on the real time. No, not this one. Where you was predicting the driver's behavior.
Oh yeah. Okay.
Yeah. So how accurate that is actually. So I just want to know
We
because
were we
yeah,
were amazed by the accuracy, actually, Sandeep. We ran some models, and we are going to publish those results as well shortly. But I would say that we were getting somewhere around 84-85% accuracy in that scenario. And the accuracy was basically lot of sometimes a lot of these behavior was similar looking, and that's why the accuracy was lower. But like for example, if a person is talking on the phone, whether it is holding left or right phone, they might be getting confused, but most of the time it was pretty good.
But in a case when driver is uh, drunk and he's driving, so how the machine is is that you are, I think, drinking water you have mentioned. Okay. But
Also, it is as long as the action is clear, it doesn't matter whether the person is drunk or not. We might have another thing trained which can see if a person is drowsy and things like that. So there are models which do that. This model is specifically focused on actions being done while driving, singing, dance, like singing, combing hair, and things like that.
okay.
And this is one of the challenges where we are opening up the data set as well. So if anyone is interested, the next AICT data, we have around 50 to 60 drivers doing different things and a camera from different views to detect what action is going on.
Okay. Right. I think
Uh,
for our
Professor Anuj,
okay, yes, Professor Venkat, yeah.
Professor Anuj, can you throw some light on Hyperloop based transportation systems?
So Hyperloop was is a concept which is very interesting because it is like magnetically elevated these tunnels where you have very less resistance and you can ideally come the what they are promising is from New York to JFK it will take say less than an hour. Sorry, from New York to California it will take less than an hour. And there are few places where these tunnels are being constructed. Usually these things would be uh, very efficient where there is space available. So like sometimes like I know that Saudi is working on something. There is some of the Hyperloop installation going on in Australia, New Zealand, where there's huge amount of land available where no one is there. But for places like India, where the population density is very high, getting that piece of land becomes very difficult and very expensive. So I would say that Hyperloop like solutions might be more useful to countries where they have big portion of land sitting empty, and US is one of them as well. Like whole of Midwest doesn't have a lot of population density, so you can build those such systems. But ability to do it in India would again depend on couple of things. Similar problems as high speed railway is like the risk of electrocution and things like that. There are other emerging technology which might be more useful in India for like there are air taxis which are happening where a drone is carrying a couple of people from point A to point B. But I don't I I don't uh, like Hyperloop would be more towards a longer distance travel, not within the city travel, and Hyperloop would be more applicable to places where there is easily available land.
Yeah, in Delhi also, like we have crores of people living. However, the metro rail network, the way it was laid down, disturbed the least.
Yeah.
You can't even imagine that one would have seen metro in such areas wherein you can't really walk non-stop even for a half a minute.
Yeah.
So you must have been to Delhi metro and other things.
Yes. I've traveled in metro.
Um,
Again, like it is very interesting that they put metro. Uh, so there is this idea of latent demand. So you think that you'll provide a system and it will improve the reduce the congestion on the roadway and things like that. But there is so much latent demand where if you provide a better system, more people are coming in. So now people are coming in from farther and farther. They are living in Ghaziabad and coming down to downtown area. So that induced demand is now you have started serving more people. The impact on congestion of what they had planned, I mean, what they had thought didn't happen as much because the number of people still wanting to come to Delhi is so high.
Yeah,
Okay.
Sandeep, are there more
Right.
questions?
Yeah. One more question I will take. Yeah, I think in the beginning you were talking about the transportation research in India. So where do you see actually, like where exactly we are right now as compared to especially to the US research, and
So
how exactly we are doing it?
So there are a lot of potential, obviously, in India, and I think we can skip some of the steps which US took. US spent a lot of money investing in fiber networks. It spent a lot of money investing in sensors which were put on the road. But in India, since we haven't invested that much money on those solid devices, we might be able to avoid that expense and directly go to more of big data sensors like cell phones. We might be able to use 4G and 5G networks instead of actually putting in fiber in the ground, which costs a lot of money. And so there are a lot of opportunities over there as well. One of the good thing in India is that if there is a smart solution, I think there is a huge adoption rate of smartphones as well. So people like to the economies of scale works out pretty well in India. As an example, EV rickshaw, the electric vehicle rickshaw in India, once people realize that you can save fuel and the gas prices, you can make money, we didn't have to work very hard for adoption of EV rickshaw. Whereas in the US, people are struggling very hard to have people adopt EV vehicles and things like that. So I think in that regard, uh, the business case of using newer technologies is much stronger in India as compared to US. Obviously, the current technology which is present on roadways might not be as good, but I think the potential is high. We still have to develop our national highway system to get there. So there is a lot of investment necessary on roadway infrastructure itself. But I think I feel we are moving in the right direction. The other thing we should not forget is that not everything which is Western is good. So like when I used to be in school, I used to ride my cycle to a lot of places. And that is a much efficient and better way of commuting. There were pockets of places where we can like just play gully cricket and things like that. That is actually livable street. Those concepts are coming back again. So if we can maintain our identity and use environmentally friendly things, we should be much better off than what US is. There are cities like Amsterdam where cars are not permitted in certain areas, only cyclists can go. So things like that should also be thought. So just copying US in everything might not be a better idea. We should find our strengths and only use the concept which actually apply for Indian conditions.
Okay, got it, got it. Thank you once again, Professor Anuj.
Thank you.
Feedback link is shared in the chat box, so we request everyone to give your valuable feedback. And please remember that those who will fill the feedback form will receive the certificate after the verification. And with this, we have come to the end of the session. And now I request Dr. MP Mishra ji to propose vote of thanks.
This is Sandeep. And first of all, I am thankful on my personal behalf as well as from the School of Computer Science to Professor Anuj Sharma ji for such a wonderful presentation. And the way he explained the things, it was full of energy, full of patience, and full of smile. So that gave a lot of conversational communication as well as a kind of body language or a kind of feeling to us. And most importantly, what you said in the last, that every type of environment or every type of working condition is having different kind of solutions. So there is no one solution for all kind of situations and the problems. And in addition to that, sir, what you explained during your presentation, that was really very touching and very nice and pinpointed. In fact, those all visuals and those all examples, I think might have taken all the participant to the actual ground situation, and it might have given a kind of feeling that how actually things can be improved with the help of technology. You very rightly said that the environment, if talking to each other, or all the component of the environment are well connected and they are working in sync in the conditions that is required, in the time constraints that is required for that particular specific solution. So definitely that will be fruitful and it will provide better results. So thank you very much, sir. Thank you for being with us. And formally, I thank to my authorities, our VC sir, our PVC madam, for providing administrative support and approvals, as well as motivating us for doing such kind of academic activities. In fact, Professor Sandeep is regularly conducting such kind of lecture series, and it is helping many, and especially to our students. And next, I would like to thank my director, Professor P.V. Suresh, for his encouragement, dynamic leadership, and the support to these kind of activities. And I'm thankful to all the participants, the faculty member, different heads of different divisions, directors, and a very special thanks to our students who has taken time and participated in this activity of academic intense conversation and the kind of new development which can provide them some kind of lead to work in this area also. So once again, I am thankful to each and everyone. And again, thank you, Professor Anuj ji, for taking your time and sharing your knowledge with us. Thanks all.
Thank you, Mr. G. And before we leave, I request everyone to switch on their camera, and we will just have a group photo so that it is for the record. So I request everyone to please switch on your camera, and I request the team to please take the group photos or screenshot. Namaskar, Jhaji. I think many they will not be able to speak. Yeah. So I think we can have yes. We are done, or are we going to take two more? Yeah, I think, yeah, let me take. So I think we are done. Okay, a few more are joining. No, I think we are done with this. So thank you very much, Dr. Anuj, for your valuable time. I know that it must be more than 12 now, or 12:30 p.m. in the night. So thank you once again for all your inputs. And definitely, I believe that our learners must have inspired by your presentation, and definitely they will look forward to talk to you in the future as well. Yeah. Thank you once again.
Thank you, Sandeep.
Thank you, Professor Anuj. Thank you very much. Thank you.
Thank you.